In this video, we will look at product to sum identities. In this video, we will learn how to use the product to sum identities. And they are, if you have the product of the sine of an angle alpha times the sine of a different angle beta, then that's equal to 1/2 times the quantity of the cosine of the quantity alpha minus beta minus the cosine of the quantity alpha plus beta. For cosine, the cosine of alpha times the cosine of beta is equal to 1/2 times the quantity of cosine of the quantity alpha minus beta plus the cosine of the quantity alpha plus beta. And finally, for the sine of an angle alpha times the cosine of an angle beta, that is equal to 1/2 times the quantity of the sine of the quantity of alpha plus beta plus the sine of the quantity alpha minus beta. There's lots of videos and lots of textbooks that can walk you through the derivation of these identities, but we're just going to take a look at some examples where we're using them. The first example says to write the product, the sine of the angle 3 times theta times the sine of the angle 7 times theta as a sum or a difference. All right, so what we have here is a product of two sine functions, right? So we have the sine of something times the sine of something else. And so we're going to use that first product to sum, or in this case, it looks like it's going to be to a difference identity. So we're going to say that the sine of 3 times theta times the sine of 7 times theta is equal to 1/2 times the quantity of cosine of the quantity, the first angle, which was 3 theta, minus the second angle, which is 7 theta, minus the cosine of the same thing, but now we're just adding. So 3 theta plus 7 theta. And all that we're expected to do is just simplify as much as we can. And sometimes there's not a lot of simplification that goes on. And I think that that may be the case in this situation. Let's see how far we can get. So I'm going to have 1/2 times the quantity, and 3 theta minus 7 theta is negative 4 theta, and 3 theta plus 7 theta is 10 theta. 10 theta. All right, is there anything else that I can do? The only other thing that I can do, because on the inside of this argument, right, you've got the cosine of negative 4 theta, the cosine of 10 theta. Those arguments are at the same, so we can't actually do that subtraction. We could distribute the 1/2 through if we wanted to, but that 1/2 would be on the outside of the cosine. It would not go into the argument of the cosine. So I think it's probably better just to keep it on the outside. The only other thing that I see that maybe we could do is involving this cosine of negative 4 theta. We know that the cosine function is an even function. And what that means is that if you have the cosine of some negative angle, then that is equal to the cosine of that same positive angle. That's what it means to be an even function. And so I can rewrite this. I'll do one last line here. I can just go ahead and say that the cosine of negative 4 theta is the same as the cosine of positive 4 theta. And the rest is already as simplified as possible. So that's it. All right, let's try some more examples. The first example on part A says to write the sine of the quantity theta over 2 times the cosine of the quantity 5 theta over 2 as a sum or a difference. So what we have going on here is the sine of something times the cosine of something else. And so looking at our identities down at the bottom, the first one we saw in the previous example was a sine times a sine. The middle identity is a cosine times a cosine. The bottom right is where we see a sine times a cosine. So that's the one that we're going to use for example A. So I'm going to say that the sine of theta over 2 times the cosine of 5 theta over 2 is equal to 1/2 times the quantity, the sine of the two angles added together. Theta over 2 plus 5 theta over 2. If I add those, I get 6 theta over 2. And 6 theta divided by 2 is 3 theta. I'm saying that out loud instead of writing it all down simply because I don't know how much space I have with these fractions, so I'm conserving my space. The second piece of this is I'm going to add the sine of the difference. Okay, so what is theta over 2 minus 5 theta over 2? I believe that's going to be negative 4 theta over 2. And if I do that division, I get negative 2 theta. All right, do this on your own. Maybe pause the video and make sure you can do this on your own. Just double check that you agree with what I've done. All right, is there anything else I can do? Well, like we saw in the previous example, the only thing I see that we could do is involving this sine function that has a negative argument. Now, the sine function, unlike the cosine function, the sine function is an odd function. And what that means is that if you have the sine of some negative angle, then that is equal to the opposite of the sine of the positive angle. That's what it means to be an odd function. So the last step that I can do here is I've got the 1/2, I've got the quantity of the sine of 3 theta, but now I'm going to bring that negative out and write minus, so the plus turns into a minus the sine of positive 2 theta. And that is it. I can't go any further than that because the argument of those sine functions are different, right? 3 theta and 2 theta, I can't do anything with those. All right, let's look at the next example. This one has actual angles in there, so we're not dealing with just a placeholder of an angle like theta. So maybe we can simplify a little bit more here. This one says to write the cosine of 11 pi over 12 times the cosine of pi over 12 as an exact sum or difference. And the identity in the middle of the page is the one that we're going to use because it is a cosine times a cosine. All right, and it looks like we're going to end up with a sum. Okay, so let me write this out. So I'm going to have the cosine of 11 pi over 12 times the cosine of 1 pi over 12. Always good to start out by writing the problem. And that is going to equal 1/2 times the cosine. I'm going to subtract the two angles. Okay, so 11 pi, I'll go ahead and write it out this time. 11, I think I've got a little bit more room. 11 pi over 12 minus 1 pi over 12. And I'll simplify that in a bit. Plus the cosine, now I'm going to add them. So 11 pi over 12 plus 1 pi over 12. Okay, so what does that equal? Well, let's see here. 11 pi over 12 minus 1 pi over 12 is 10 pi over 12, which reduces to 5 pi over 6. Aha, I like that because that's an angle that I do know. That's one of my special angles, so I know the cosine of it. For the second piece, 11 pi over 12 plus 1 pi over 12 is 12 pi over 12. So the 12s cancel out and I'm left with pi. That's also one of my special angles. Great. Okay, so let's go ahead and write out what is the cosine of 5 pi over 6. All right, so let's think about your unit circle. 5 pi over 6 is all the way over into the second quadrant. So we know it's going to be a negative value, and if you think about this for a little bit, it should be negative square root of 3 over 2 plus, what's the cosine of pi? Cosine of pi is negative 1. Okay. All right, so I think the only thing here. I mean, there's a couple things I suppose I could do. I could add on the inside, but I think before maybe I think about that, I'm gonna just go ahead and distribute that 1/2 through. Now I'm doing it on this one where I didn't do it before, simply because I feel like it's going to make a difference, right? Like I have actual numbers, you know, up on part A, to distribute 1/2 and just have it sitting on the outside of the sine function didn't really feel like it was doing anything. But in this example, if I take 1/2 times that first term, negative square root of 3 over 2, it is going to look a little bit different. This is going to become negative square root of 3 over 4. And then if I distribute it to the -1, 1/2 times -1 is negative 1/2. And that's a really great answer. If you want, we could probably simplify that a little bit more. We could find a common denominator. I'm running out of room, so I'm going to put this all together. Find a common denominator, and I could write negative square root of 3 plus negative 2 all over 4. So, you know, let me just highlight this. I would think that this is a possible answer without combining the denominators. This is also a really nice answer. I sort of like that a lot because, you know, if you can combine denominators, why not do it? I have seen books go even one step further and factor a negative out of the numerator. If I factor a negative out, I'm going to have this negative just sitting on the outside, and then the negative square root of 3 turns into positive, and the negative 2 turns into a positive, and then I have a 4 on the bottom. All right, so that may feel a little tricky, and if you have questions, please go ahead and comment, ask me about those, and I'll try and clear it up. But it's just an algebra thing or arithmetic thing, so I bet you've got that figured out.